The snow didn't melt. It burned. 80 miles from ground zero, 23 fishermen watched a second sun rise in the west, so bright it seared through their eyelids, turning the Pacific into a mirror of impossible light. 7 minutes later, the sky began to fall. White flakes collected on their palms, tasted like copper, left red welts where they touched skin. The U.S. military had declared these waters safe. They'd done the mathematics, calculated the fallout radius to the exact nautical mile, triple-checked every projection. Their instruments said the fishermen were outside the danger zone. But while the Navy was measuring what they'd built, the bomb was teaching itself to become something else. Mid-detonation, the weapon found a fuel source that shouldn't exist. Atoms physicists had sworn would stay inert, now feeding a reaction that rewrote the rules of nuclear fire. Not an error in the calculations, a betrayal by physics itself. Radio operator Eikichi Kuboyama brushed the ash from his hair, his shoulders, the deck of Lucky Dragon number 5. He didn't know his white blood cell count was already collapsing. Didn't know the fallout blanketing his skin contained atoms the military's dosimeters weren't designed to detect. By the time Navy ships arrived to enforce an exclusion zone that no longer meant anything, the crew had been breathing the impossible for 3 hours. This is Castle Bravo, the day we detonated a weapon that refused to obey the laws we'd used to build it. And 23 men paid the price for a reaction that was never supposed to happen. Kuboyama and 22 crew members had deployed long lines for tuna in international waters, having monitored U.S. radio warnings of a 60-mile exclusion zone around Bikini Atoll. They were outside the announced danger perimeter by a comfortable margin, 20 miles beyond the boundary. The crew worked the lines in calm seas, hauling yellowfin and big-eye tuna that would fetch good prices in Japanese ports. The morning of March 1st, 1954, began as a routine fishing day. They had no reason to believe the U.S. Atomic Energy Commission had miscalculated the blast radius, or that the weapon about to detonate was fundamentally different from earlier tests. At 0645 local time, a white flash illuminated the western horizon. The crew stopped work and turned toward Bikini. A fireball rose, larger than any previous test they had heard about on the radio. The light was so intense that men shielded their eyes even at 80 miles distance. The fireball climbed and spread, forming a mushroom cloud that reached the stratosphere in minutes. Kuboyama recorded the time and bearing in the ship's log. The crew watched in silence, knowing a weapon had been detonated, but unable to judge its size. The scale of the flash suggested this test was far more powerful than the 6 megaton maximum the U.S. had announced for Castle Series testing. 7 minutes later, the shock wave reached the boat. A pressure wave rattled the rigging and vibrated through the hull. Loose gear shifted on deck. The crew braced against the rail as the wave passed. The delay between flash and shock wave confirmed the blast was roughly 80 miles away, matching their calculated distance from Bikini. But the intensity of the pressure wave suggested the yield was much larger than expected. The crew exchanged glances. They were outside the exclusion zone, so they continued to work the lines. No evacuation order came over the radio. The U.S. Navy had not yet realized the bomb had exceeded every prediction. White ash began to fall an hour after the flash. It drifted down from the upper atmosphere, covering the deck and clinging to the crew's hair and clothes. The particles had no odor. They felt gritty, like fine sand or coral dust. But within minutes, the ash began to burn skin on contact. Crew members brushed it off their arms and necks, leaving red welts. Kuboyama noticed the ash accumulated in the folds of his shirt and under his collar. The crew had no frame of reference for radioactive fallout. They assumed the particles were coral debris lifted by the blast, unpleasant, but not deadly. No one suggested evacuating the deck or washing down with seawater. The crew continued to haul lines for several hours, unaware the ash was radioactive. Lucky Dragon number 5 carried no Geiger counter or dosimeter. Commercial fishing boats had no reason to stock radiation detection equipment. The crew had no way to measure the invisible threat accumulating on their skin, in their lungs, and in the fish they were hauling aboard. Kuboyama and the others worked through the morning, breathing air thick with fallout particles. By the time they finished the day's catch, each man had absorbed a dose that would take months to kill. The U.S. Navy had not yet issued a warning because test directors at Bikini had not yet confirmed the yield exceeded the exclusion zone calculation. The scientists had made a calculation. The U.S. Atomic Energy Commission set the danger zone at 60 miles, built entirely on one number: 6 megatons. That's what their fallout models promised. Contamination contained within that radius, dose rates dropping to safe levels beyond the perimeter. But that 6 megaton prediction rested on an assumption about the bomb's fuel. Los Alamos physicists had designed Castle Bravo's secondary stage using lithium deuteride, a solid compound easier to handle than liquid hydrogen. Inside that fuel sat 2 types of lithium. Lithium-6, just 7.5% of the mix, would breed tritium and feed the fusion reaction. The rest, 92.5% lithium-7, would do nothing, stay inert, sit there like dead weight. At least, that's what they assumed. The weapon's predicted yield of 6 megatons depended entirely on that assumption being correct. The exclusion zone, the evacuation radius, the safety of everyone within 60 miles, all of it calculated from that single number. But what if the bomb found extra fuel that wasn't supposed to be there? Lucky Dragon number 5 carried no radiation detection equipment because no commercial fishing boat did. The crew interpreted the white ash as coral dust or volcanic debris, particles lifted by the blast and carried downwind. They had no reason to suspect the ash was laced with fission products. Kuboyama had heard radio reports about atomic tests in the Marshall Islands, but the broadcast never described fallout or explained how to recognize radiation hazards. The crew had no training in radiological safety. Even if they had suspected the ash was dangerous, they had no means to measure exposure, no decontamination procedures, and no protective clothing. Their only option was to continue fishing and trust the U.S. exclusion zone boundary. Back at the Bikini, Los Alamos physicists waited for instrument readings. The test array included dozens of sensors mounted on barges and islands downrange, designed to measure yield, pressure, and radiation flux. But the fireball had vaporized most of the downrange sensors. Instruments that survived the initial flash were obliterated by the thermal pulse, or buried under tons of vaporized coral. The physicists had no real-time yield data. They knew the explosion was larger than expected because the fireball was visible from ships 60 miles away, but they did not yet know how much larger. Without instrument telemetry, they could not calculate the actual fallout radius or issue revised evacuation orders. The safety officers held up their radiation badges, small film strips designed to darken gradually over months of exposure. These badges could measure up to 1,500 rads of X-ray and gamma radiation, standard for medical and industrial work. But thermonuclear fallout doesn't play by those rules. It throws alpha particles, beta particles, and neutrons, a radioactive cocktail the badges were never built to handle. Within hours of the test, badges at forward observation posts had turned completely black, maxed out. The officers stared at solid black squares that could mean 1,600 rads, or 6,000 rads. They had no way to tell. The dosimeters screamed that contamination was severe, but couldn't answer the questions that mattered. How severe? How far had the fallout spread? That data gap cost time. Evacuation orders for ships and atolls outside the original 60-mile zone sat unissued, while men tried to read instruments that had gone blind. Radio operators at Bikini kept broadcasting the same message: 60-mile exclusion zone. Ships and fishing boats beyond that line received no warning. No expanded evacuation order went out. The test directors were flying blind. No instrument telemetry, film badges maxed out, no hard numbers on the actual yield. They didn't yet know the bomb had exceeded predictions by a factor of 2.5. The Atomic Energy Commission's protocol was clear. Confirmed yield data before expanding the danger perimeter. Without those numbers, no justification for a wider evacuation. so the radios stayed silent. And on Rongelap, Outrage, and Eilingene atolls, all more than 100 miles from ground zero, Marshallese families went about their daily routines as fallout drifted over their islands. By mid-afternoon, several crew members reported nausea and headaches. Kuboyama's skin showed reddening where ash had contacted his bare arms and neck. The burns were not like sunburn or heat blisters. The tissue underneath felt tender, as if bruised from the inside. Other crew members complained of metallic taste in their mouths and dizziness. The captain gathered the crew and inspected the white ash covering the deck. It had been falling for hours and now lay in drifts along the gunnels. He suspected the ash might be dangerous, though he did not know it was radioactive. The symptoms were escalating too quickly to be food poisoning or heat exhaustion. The captain ordered the boat to head east toward Japan at full speed. He did not know the ash was radioactive, but the crew's symptoms convinced him they needed medical attention. The nearest port was Yaizu, more than 2,000 miles away. At the boat's maximum cruising speed of 8 knots, the voyage would take nearly 2 weeks. The crew spent another 12 hours on deck hauling and stowing gear, washing down the boat, and securing the ketch. Every minute of that work exposed them to the fallout still covering the deck. They had no protective clothing and no understanding that washing with seawater would not decontaminate radioactive particles embedded in the wood and rigging. Fallout drifted northeast on upper atmosphere winds, depositing radioactive particles on Rongelap, Outrage, and Eilingene atolls. 236 Marshallese lived on those islands, most of them on Rongelap, 100 miles downwind from Bikini. They had received no warning. The white ash began falling in the late morning, hours after it had reached Lucky Dragon. Families watched the snow-like particles accumulate on roofs, pathways, and the lagoon surface. It was unlike anything they had seen before. Children played in the ash, unaware it was deadly. No U.S. personnel were stationed on Rongelap to warn them or measure radiation levels. On Rongelap, children played in the white ash, and families continued to eat reef fish and drink from catchment cisterns. The cisterns collected rainwater from roofs now covered in fallout. Every sip delivered fission products directly into their bodies. The fish they caught in the lagoon had been swimming through contaminated water, concentrating radioactive isotopes in their flesh. No one on the atoll understood the danger. They had no Geiger counters, no dosimeters, no radio contact with U.S. authorities. The Navy knew the test had occurred, but communication delays and the lack of confirmed yield data meant no evacuation order had been issued. The Marshallese continued their routines, absorbing dose with every meal and every breath. U.S. Navy radiological teams finally confirmed that film badges on Bikini had maxed out, indicating exposures far beyond the planned zone. The test directors now understood the yield was significantly higher than 6 megatons, but they still lacked precise numbers. Aerial reconnaissance flights began mapping the fallout plume, using portable Geiger counters to measure contamination on ships and islands downrange. The data showed radiation levels remained dangerously high, more than 100 miles from ground zero. However, communication delays prevented immediate evacuation orders. It would take another 48 hours to coordinate ships, aircraft, and landing craft to reach the affected atolls. Those 48 hours would matter. Castle Bravo's secondary stage used lithium deuteride fuel, a solid compound of lithium and deuterium. Designers chose it because solid fuel was easier to handle and store than liquid hydrogen. Natural lithium contains 2 isotopes, lithium-6, which makes up 7.5%, and lithium-7, the remaining 92.5%. Los Alamos physicists knew lithium-6 would absorb neutrons from the primary fission stage and breed tritium, a heavy isotope of hydrogen that fuses readily and releases energy. They assumed lithium-7, with 1 extra neutron, would not participate in the reaction. The yield calculation was based on lithium-6 breeding alone, producing an expected 6 megatons. That assumption was about to be proven catastrophically wrong. When the primary fission stage detonated, the neutron flux was intense enough to convert lithium-7 into tritium. The reaction was lithium-7 plus a neutron, yielding helium-4, tritium, and an additional neutron. Los Alamos physicists had not predicted this pathway would occur at significant rates. But the neutron energies inside the fireball were higher than expected, and lithium-7's cross-section for that reaction turned out to be large enough to matter. Each lithium-7 nucleus that fused released an additional neutron, which could then trigger more lithium-7 reactions. The result was a cascade. The inert fuel suddenly became active, multiplying the reaction rate and adding roughly 10 megatons of unplanned yield to the explosion. The 15-megaton fireball vaporized 3 islands: Boconigian, Aerocoilo, and Nam. The thermal pulse turned coral limestone into vapor in milliseconds. The fireball lifted 10 million tons of coral and seawater into the stratosphere as radioactive particles. The blast cratered the seafloor, leaving a depression 2 miles wide and 250 feet deep. The mushroom cloud reached an altitude of 25 miles, punching through the tropopause and spreading fallout into the stratospheric jet stream. Instruments that survived the initial flash recorded surface temperatures exceeding 5,000 degrees Fahrenheit at distances where the 6-megaton prediction had forecast survivability. The weapon had exceeded every engineering assumption. Death rained from the sky. The cloud didn't just drift, it hunted. Fine particles, barely visible specks ranging from 0.1 to 10 microns in diameter, stayed suspended for hours, riding the wind over 100 miles downwind like a silent plague. Larger particles, tens to hundreds of microns, plummeted within minutes, blanketing everything near ground zero in radioactive ash. The fireball's rage had vaporized the coral itself, which condensed around fission products as the cloud cooled into something far more sinister. Each particle, every single speck of fallout, carried isotopes of cesium, strontium, iodine, and plutonium. Wind shear in the stratosphere caught the plume and shoved it northeast, directly over Rongelap and toward the shipping lanes where Lucky Dragon fished, oblivious. At 80 miles from ground zero, the dose rate hit an estimated 100 rads per hour at peak fallout. 4 to 6 hours of unprotected exposure. That's all it would take to deliver a lethal dose. Lucky Dragon number 5 reached Japan on March 14th. All 23 crew members showed signs of acute radiation syndrome, vomiting, hair loss, and skin burns. They were hospitalized in Yaizu and Tokyo without an initial diagnosis because the doctors had never treated radiation exposure of this severity. Blood tests revealed catastrophically low white cell counts. The crew's symptoms matched descriptions of radiation sickness from Hiroshima and Nagasaki, but the exposure pathway was different. These men had absorbed dose from external contamination and inhalation, not prompt radiation from a detonation. Japanese health officials contacted the U.S. Atomic Energy Commission to request details about the March 1st test. On Bikini, the Navy dispatched a single landing craft to evacuate Rongelap Atoll, 48 hours after the test. 236 Marshallese boarded the craft with no decontamination and no medical screening for radiation injury. The landing craft had no showers, no protective clothing, and no radiation detectors. Evacuees brought contaminated belongings and food with them. The delay meant they had spent 2 full days drinking contaminated water, eating contaminated fish, and inhaling fallout particles. Navy medical officers would not assess their exposures until they reached Kwajalein Atoll, another day away. The evacuation was competent given the resources available, but those resources were catastrophically insufficient for a radiological emergency of this scale. Children on Rongelap had already absorbed thyroid doses exceeding 1,000 rads from inhaling and ingesting iodine-131 in the fallout. Iodine-131, a fission product with an 8-day half-life, concentrates in the thyroid gland. Young children with smaller thyroid glands and higher metabolic rates absorbed the highest doses. The evacuation delay guaranteed elevated cancer risk within a decade. Navy medical officers measured external contamination levels on the evacuees, but had no way to assess internal dose from inhaled and ingested isotopes. The Marshallese would spend the next 3 years displaced from their home islands, while the U.S. conducted long-term health monitoring and decontamination efforts.
Japanese health officials traced the crew's illness to radiation exposure and tested the boat's catch. Tuna from the contaminated zone tested positive for cesium-137 and strontium-90, both long-lived fission products that bioaccumulate in fish tissue. The contamination was orders of magnitude above safe consumption levels. Officials immediately quarantined the catch and began tracing fish from Lucky Dragon that had already entered the supply chain. Hundreds of tons of tuna were destroyed. The news triggered panic across Japan. Consumers stopped buying tuna. Markets reported losses in the millions of dollars. International media demanded an explanation from the U.S. Atomic Energy Commission. The disaster had escalated from a radiological accident to a diplomatic crisis. Panic spread across Japan as hundreds of tons of irradiated tuna were destroyed. The tuna industry lost millions of dollars. Fishermen returned to port to avoid the contaminated zones, but no one knew how far the fallout had spread or which fishing grounds were safe. Geiger counters appeared at fish markets nationwide. Consumers refused to buy tuna regardless of origin. International media coverage amplified the crisis. Headlines accused the U.S. of reckless testing and concealing the true danger zone. Diplomatic pressure mounted. Japanese officials demanded compensation and full disclosure of the weapon's yield and fallout patterns. The Atomic Energy Commission could no longer avoid acknowledging the Lithium-7 miscalculation. Eikichi Kuboyama's bone marrow failed over 6 months, despite blood transfusions and experimental treatments. Radiation had destroyed the stem cells responsible for producing white blood cells, leaving his immune system unable to fight infection. He developed hepatitis and liver damage, complications common in radiation victims. On September 23, 1954, Kuboyama died. He became the first confirmed fatality of a U.S. thermonuclear test. His death made international headlines. Japanese officials issued a formal protest. The Atomic Energy Commission could no longer deflect responsibility. Kuboyama's final words, according to hospital staff, were a plea that he be the last victim of nuclear weapons. The Atomic Energy Commission publicly acknowledged the Lithium-7 fusion contribution and the yield miscalculation. Officials admitted that natural lithium's isotope composition had produced a reaction pathway the design team had not anticipated. The weapon's actual yield was 15 megatons, 2.5 times the predicted 6. The commission issued payments to the Lucky Dragon crew and the Japanese government as compensation for medical costs, lost income, and damages to the fishing industry. The acknowledgement did not prevent the U.S. from continuing thermonuclear testing, but it forced a revision of safety protocols and exclusion zone calculations for future tests. Marshallese evacuees from Rongelap and Outrage remained displaced for 3 years while the U.S. conducted decontamination efforts and long-term health monitoring. Some islands remained too contaminated for resettlement. Residents who returned faced elevated cancer and thyroid disease rates for decades. Children exposed to fallout developed thyroid nodules, cancer, and growth abnormalities at rates far exceeding national averages. The U.S. government established a medical monitoring program that continues to this day, tracking health outcomes in the affected population. Compensation programs were implemented, but many Marshallese argue the payments have never matched the scale of the harm. The displacement and health crisis remain the longest-lasting consequence of Castle Bravo. Castle Bravo's fallout radius in international outrage accelerated atmospheric test ban negotiations. The incident became a key argument for opponents of open-air testing. Scientists and diplomats cited the unpredicted yield and the failure of exclusion zones as evidence that fallout could not be reliably contained. Public pressure mounted, especially in Japan, where the memory of Hiroshima and Nagasaki amplified fear of nuclear contamination. The Soviet Union and the United Kingdom
joined the US in preliminary talks. Those discussions would culminate in the Limited Test Ban Treaty, signed in 1963, which prohibited nuclear weapons tests in the atmosphere, outer space, and underwater. Castle Bravo was not the sole cause, but it was the most visible failure that made the risks undeniable.
The 23 fishermen. Hundreds of Marshallese. They paid the price first. Los Alamos scrambled to revise thermonuclear weapon design protocols, accounting for lithium-7 breeding. Every subsequent U.S. test used enriched lithium-6 fuel to eliminate the unpredictable contribution from lithium-7. Exclusion zones expanded. Fallout models updated with data from Castle Bravo's actual dispersion pattern. Radiological safety teams received upgraded dosimeters capable of measuring mixed alpha, beta, and neutron flux. The doctrine shift improved safety margins. But it came too late. Castle Bravo remains the largest nuclear weapon the United States has ever detonated, the worst radiological disaster in U.S. history. And for the survivors, the fishermen who lived, the Marshallese who returned to contaminated soil, it left something protocols could never measure. An invisible scar, burned into skin and memory, on islands that would never be whole again. The white ash that fell on Lucky Dragon number 5 was not coral dust. It was a weapon, teaching itself to become more powerful mid-detonation. Atoms that should have stayed inert, multiplying a fireball beyond every calculation. 80 miles should have been safe. The 60-mile exclusion zone should have been conservative. But the bomb did not obey the predictions. 23 fishermen and 236 Marshallese paid the price for a reaction that was never supposed to happen. Eikichi Kuboyama's death forced the world to confront the reality that thermonuclear fallout could not be contained by mathematics alone. Castle Bravo remains a lesson in the limits of prediction when the physics you are controlling can rewrite itself faster than you can measure it.